In this video, we're going to focus on a common geometric figure, which is two lines being crossed by a transversal. This will probably be a two-part video. First, let's go through some of the definitions. What is a transversal? A transversal is any line that intersects two or more distinct coplanar lines. So if you have two lines like this, and a third line that crosses both of them, all lying on the same plane, then line T would be a transversal. Notice that the lines that it crosses don't need to be parallel. It's just that some interesting things happen when they are parallel. Another word that is often used when you're talking about lines are concurrent lines. Concurrent lines are three or more lines that intersect at a single point. So if I have two lines, those are just intersecting lines. That happens all the time. If I have a third line that intersects at that same point, so all of those three lines intersect at the same point P, then the three lines L, M, and N would be considered concurrent lines. And you can have more than three. You could have four that intersect at that point, or five, or however many. So with transversals, we've got a transversal here. A transversal is the line HE. I'm going to give myself another point down here. I'll call that point L. So we've got HL as the line. So HL is the transversal. And notice that HL intersects lines CD and lines IG. And in doing so, it creates a number of angles around those vertices. So angles that are in the same position around the vertex. So for example, angle 1 and angle 2 are both in the upper right-hand side of that vertex. They'd be considered corresponding angles. So angles 1 and 2 are called corresponding angles. Other corresponding angles would be, for example, let's say angle, and I'll use the letters, CFH, which would be this one. So angle CFH and angle IEF. Both of those are in the upper left-hand side of the vertex. Alternate interior angles, it's very descriptive. The word's very descriptive. Alternate means they're on opposite sides of the transversal. Interior means that they are on the inside of these intersected lines. So this is the interior portion of the line. So alternate interior would be angles such as angle 3 and angle 1. They're on the opposite side of the transversal, and they are interior. They're within the two parallel lines. So angles 1 and angle 3 would be alternate interiors, or AIAs. You could also have angle IEF and angle EFD. So angle IEF and angle IED. Alternate exterior, again, what the name implies. Alternate means they're on opposite sides of the transversal. Exterior means they lie outside of these intersected lines. So this is the exterior portion. Exterior alternating. So line CFH, or angle, CFH, and angle LEG, angle leg, would be alternate exterior, or AEAs. They are exterior to the intersected lines, and they're on opposite sides of the transversal. Would be angles 2, angle 2, and angle 4 down here would also be alternate exterior angles. Lastly, angles that are consecutive interior. Interior means they lie within the intersected lines. Consecutive means they lie on the same side of the transversal. So angle 1 and angle EFD they lie on the same side of the transversal, so they're consecutive angles, and they're also interior, meaning they're within the intersected lines. Angle 3 and angle IEF would also be consecutive interior angles, or CIAs, consecutive interior angles. Now, what do we know about these? This is not just that they exist and they have names, but there's some interesting facts. So I've got a figure here, which looks like, so it appears from the figure, if I've got the intersected lines, say CD and IG, CD and IG are obviously not parallel. They appear to intersect somewhere down in this direction. And so what do we know? It doesn't look like the different pairs of angles are congruent. For example, here's two corresponding angles around line CD and line IG, and the angle 1 looks to be a little bit bigger than angle 2. But if the intersected lines are parallel, so in other words, if a transversal intersects parallel lines, it appears that, for example, the corresponding angles are congruent. So angle 1 and angle 3 appear to be the same size, but looks can be deceiving. So I have created a little figure here on it's an app called GeoGebra, and I can move this around, and I actually have measured the angles. So here we go. I've got these measurements. Notice lines CD and IG are not parallel, and what I can do is I can actually grab this and make them even less parallel. Notice that angle HFD, which is 37.9, and say angle IEA, 47.96, those are alternate exterior angles. They're nowhere close to being the same. But notice what happens around for these angles when the lines are parallel. Angle IEF, which is 132.4, equals angle JAE, which is 132.4 degrees. All right, those would be corresponding angles. Angle IEF and angle KAB are also 132.4. Those are alternate exterior angles. How about the alternate interiors? 47.96 IEA, 47.96 BAE, excuse me. Alternate interiors are also congruent. Lastly, notice that I have consecutive interiors, 47.96, 132.04. If you add up those consecutive interiors for parallel lines, if the lines are parallel, they are supplementary. When you add up those measures, they'll equal 180 degrees. So, just to summarize what we know about transversal angles, we've got a set of theorems. Actually, one is a postulate. A postulate is something that we're going to assume is true. We wouldn't derive it or prove it. And there are 4 parallel line theorems that are sort of common. There are actually a few others, but these are the 4 that we'll focus on. Corresponding angles postulate. 2 lines cut by a transversal are parallel if and only if the corresponding angles are congruent. Now, the if and only if means that if the 2 lines cut by a transversal are parallel, then the corresponding angles are congruent. It also means, so in other words, it goes from parallel lines to congruent corresponding angles. Corresponding angles congruent. It also means if and only if is a specific mathematical term. It also means the reverse is true. If the corresponding angles are congruent, then I also know that the lines cut by a transversal are parallel. The same is true for the other 3, and these are theorems because they can be derived or basically arrived at through the corresponding angles postulate. If 2 lines are cut by a transversal and they're parallel, alternate interior angles are congruent. Likewise, if the alternate interior angles are congruent, the lines cut by a transversal are parallel. For alternate exterior angles, again, if the lines are parallel, the AEAs are congruent and vice versa. And lastly, if the two lines cut by a transversal are parallel, the consecutive interior angles are supplementary. And remember, for supplementary, that means, for example, that the measure of angle 1 of one of the consecutive interiors plus the measure of angle 2, the other consecutive interior, equals 180 degrees.